Okay, we're now going to look at Vout. Again, but this time a past paper question. So you can't see this very clearly, but I'll draw this out. This is in the homework booklet, the past paper question booklet. So there's a resistor. This is the voltage we deal with. Here's another resistor in line. This is R1. This is R2 because that's the positions they are in. This is a variable resistor, VR1, and this is actually LDR, which is just called T1. Yeah, there's 9 volts there. There's 0 volts there, and it says under certain light conditions VR1 is equal to 100 to 50k is equal to 50k, and T1 is equal to 10k. Now we know from our sort of looking at relationships of voltage and dividing voltage, that is 5 times as big as that. So this voltage here will be 5 times as big as that, and they've both got to add up to 9 volts. So we've got a rough idea of where it should sit. The formula we're using is, go back to the formula sheet, which is in the booklet. V out is equal to R2 R1 plus R2 times by the voltage supply, which is 9 volts. So that's the formula we're dealing with. So if we move that out of the way, we turn over the page, we write the formula again. V out is equal to R2 over R1 plus R2 times by Vs. Now for that circuit that we've just had, we go back, V2 is 10k and V1 is 50k. So it's 10k over 50k plus 10k times by the 9 volt supply. That's V out. We're looking for a voltage, remember. So we can now simplify that. So it's 10k divided by 60k times by 9 volts. Well, that can cancel with that. So we've got 10 divided by 60 times by 9. So if we use the calculator, calculator's on, 10 divided by 60 equals that, times by 9 equals 1.5 volts, is equal to 1.5 volts. So going back to the question originally, that means that that voltage there is 1.5 volts. That means that this voltage here is 1.5 volts. If we were to put a transistor just here, connecting that up, and perhaps putting a buzzer just there, connecting that up, 1.5 volts is across that resistor. That means the 1.5 volts is there. So this means that the 1.5 volts is here. So therefore the transistor is on.